Okay, so line integral on conservative vector field. What do you mean by conservative vector field? We already done the definition of conservative vector field, right? When we started with vector field, I gave you the definition of conservative vector field. So see the vector field who is the gradient of some other potential function. So that vector field is called conservative vector field, isn't it? Do you remember this?
Yeah.
So if f is conservative, if and only if, okay, this I double f means if and only if f is equal to gradient of small f, right? For some potential function f, right? This was the definition of conservative vector field, right? If the capital F is conservative, that happen only if it is a gradient of some other potential function, right? Now, so far, like in the previous
Hmm.
lecture, we applied the line integral over vector field, simply vector field, right? We didn't talk about whether it is conservative or non-conservative vector field, isn't it? We applied the line integral, right, over vector field. This was the expression of the line integral, right? Where capital F is the vector field
Hmm.
along the curve C. Got the idea? We have integrated the
Hmm.
line integral along the curve C. That curve C is significant in that case. But like in case of conservative vector field, this integration become more easier. Got the idea here? Like we don't have to do much integration. Like we need to convert all these like curve as well as the given vector field in terms of parameter equation. Now those stuff can be reduced, those working can be reduced if we have conservative vector field. Okay. See, the conservative vector field is independence on the path. Like if we have 2 points and we we need to move a particle from point A to point B, right? Through some vector field.
Hmm.
So we need to do some work, right? The work has to be done to move a particle from point A to point B, right? Through some of the
Hmm.
vector field. And the vector field is nothing but, we know that that's flow of some substance, maybe electric charge or some force field, right? So the work has to be done if we want to move a particle from A to B, right? But like if the vector field is conservative, one of the property of being conservative vector field is the it is independence on the path. Okay, means whatever path we choose to move a particle from A to B, how many paths are there? If I want to move a particle from A to B, how many paths we may have?
Infinite.
Infinite.
Infinite path. So what this conservative means here is if we have a conservative vector field, the work done to move a particle from A to B is constant, okay, no matter which path you choose. Okay, that's the meaning of conservative vector. Like if we have a conservative vector field, the line integral is independent on path. So if we have to find out the work done, see this is the formula of work done, right? So line integral is independent on path if we have a conservative vector field. Got the idea here?
Hmm.
Means whatever path you choose, that doesn't matter. The work done is going to be same. It's going to be constant. Only matters is those endpoints. Those endpoints must be same. Okay. Unless the
Hmm.
endpoints are constant or they stay same, the work done is constant, no matters which path you
Hmm.
choose. Did you understand? This is the advantage of having conservative vector field. The gravitational field, like gravitational force field and electric field are the conservative vector fields. Okay, so work done
Yeah.
in those vector fields is constant if we have same endpoints. Okay, so let's summarize this concept here. The line integral is independent on path, so the integral will be the same no matter what curve we choose, as long as endpoints stay the same. Okay, so what is the advantage of having this conservative vector field? If suppose this curve doesn't matter, means, are you getting that? If we want to move a particle from A to B, we can choose any path. The work done has to be same, right? So what does not matter here is the path we choose. Are you getting that? So we no need to define the curve here. Are you getting the advantage of having this conservative vector field? We no need to define the curve. Like, do you remember
Right.
in the previous examples, we need to define the curve and we need to define the vector field in terms of parameter equation, and then we find out the dot
Yeah.
product and we integrate, right? All those workings are reduced in this case. That's the advantage of having
Got
conservative vector field. Okay, now we'll see how it happens, like why those working are reduced. Like one thing you can understand here, that the if line integral is independent on path, so we no need to define the curve here. Are you getting the idea? We just want those endpoints, because we can go through any curve, the amount of work done is constant, so no need to define the curve, right?
mm.
So for conservative vector field, we don't even define a curve C. Okay, now can we recall like one thing called fundamental theorem of calculus?
Yeah.
What is that?
Yes. Uh, it's basically when you say when there's a small h and the limit and the h approaches zero and then you prove, right? Is it that one?
Calculus, like in definite integration, we saw this a to b. I'm talking about the second fundamental theorem of calculus. So a to
Oh,
b, if we have f dash x dx,
so, yeah.
what should I write?
It
Like, what would be the
exists a
answer?
C.
If we have a, this is the derivative of some function, okay? Derivative of f of x. So now if we apply integration, can we write f of b minus f of a, right? What is the entire derivative of f dash
Oh,
x? That's f of x. See, this is the, we have done a lot, long before. You know this stuff, right?
yeah,
If we have f dash x, so entire
yeah,
derivative of f dash x is f of x. We apply the definite integration. So this is called fundamental theorem of calculus. Okay. Now, see, as I told you, when we have a conservative vector field f, okay, so it is a
yeah.
gradient of some other potential function. So can we write this? A vector field is same as the gradient of some potential function. Do you remember this? See, this del f was nothing but fx I cap plus fy j cap. So these are the just function,
Hmm.
right? And our
Hmm.
vector field was like p I cap plus q j cap. So aren't they same thing? So this happens if like this vector field is a conservative vector field only when this is gradient of some other function f. Okay,
Okay.
that's the definition. So if we have f
Hmm.
is equal to del f, okay, what is this? That certain type of derivative of f, right?
Hmm.
Isn't it? That del f is some type of derivative of f. Do you remember this? For,
Hmm.
let's say, for some function, for function f, right? That is the gradient function. So gradient is a, you know, it's a derivative of f, right? Now if like we have, we can write one thing here, that if del f is gradient of f, then what is f? What is small f?
The integral, like, so in the
Antiderivative. F
it'll,
is
yeah, and
antiderivative of del f, right?
so
Yeah,
so
yeah,
wouldn't you have three three ways of getting back to f?
yeah. That
You
that
can do
that's what we required in this section. See, you raised this question, I think, two lecture before when we were
but
discussing
yeah,
about
two
the
classes ago.
this conservative vector field. I gave you the definition of conservative vector field, like what I'm giving you right now. So that time only I told you this will
Yeah,
come after two class, right? So now it is
yeah, yeah,
here in front of you. So f is the antiderivative
yeah.
of del f. So actually the big problem is we need to find out f here. That is, you will see after one or two statements that we are concluding this topic with a big problem, that is we need to find out f. So the whole lecture is like based on this, we need to find out that potential function. Okay, so let's see how it
Hmm.
happens first of all. So f is the, you know, antiderivative of del f, because del f is the gradient of, f. Got this idea here?
Mhm.
Okay, so if suppose f be a conservative vector field, okay, so if f be a conservative vector field, what we can say about f? F is del f, right? F is del f for some f, isn't it?
Hmm.
Now if suppose I have to
Hmm.
apply the line integral over this vector field, this f will be replaced by this del f, isn't it? Now, now here it
Yes.
comes.
Yeah.
So if we have a, like, see, this is the gradient of some other function. It is a gradient of some potential function. So what would be the antiderivative of that? See, we are doing antiderivative of del f. So what is the antiderivative of this del f?
F.
F, right? So we, if we
Yeah.
have two
Yeah.
endpoints a and b, we can simply apply the fundamental theorem of calculus to find out the work done here. Got the idea here? The only problem left is we don't have this f. We don't have f. The function is not defined. We only have the vector field. We don't have the potential function, right?
Yeah. So could you scroll up a bit?
Yeah, let me just wind up this concept. So this is called fundamental theorem of line integral. Okay, so is it okay?
Hmm.
So now we're trying to find f.
F. Okay, now our job is to find out the potential function f. See, this works only if we have a conservative vector field. See, if we have a conservative vector field, then only we can make this relation, isn't it? Right? So we need to do two things here.
Yeah.
Yeah.
The first is we have to prove or we have to show that the given vector field is conservative vector field first. Okay, and the second is we have to find out f, the potential function, if the given vector field is conservative vector field. Got the idea here?
Hmm.
Okay, so see, to show the given vector field is conservative, it's very simple. We have to just show, like, write down the heading, show f is conservative. So f is like f of x comma y is equal to p I cap plus q j cap, right? Or if it is in three dimensional coordinate system, then the f of x comma y comma z is p I cap plus q j cap plus r k cap. We differentiate this p. Now listen, we differentiate this p with respect to y. Okay, and we differentiate q with respect to x. If they are equal, then the given vector field is conservative.
Hmm.
Del q by del x, right?
Yeah. So see, this is basically curl. If you can relate the concept, this is basically curl equal to zero. Now, if we have this, right? So you'll have to check one thing, that curl has to be zero. Curl of this f has to be zero if the given vector field is conservative vector field. So what would be the expression in that case? I j k del upon del x, del upon del y, del upon del z, right? And p q r. So this is curl, right? This is curl of f. Do you remember this?
Hmm.
Yeah. So I, we can write I later, but del r upon del y minus del q upon del z I cap minus del r upon del x minus del p upon del z j cap plus del q upon del x minus del p upon del y k cap. Okay, so this has to be zero if the given vector field is conservative vector field. It means this, that difference must be zero. Okay, means del r upon del y should be equal to del q upon del z, del r upon del x should be equal to del p upon del z, and del q upon del x should be equal to del p upon del y. So if curl is zero, or we equate these expressions, so basically we just find out curl to find out whether the curl is zero or not. So if curl is zero, the given vector field is conservative vector field. That is what we have to show.
So,
Yeah.
in the for the two-dimensional one, have you written the correct form?
The
Del
two,
P del Y
see,
is equal to
that
del
will be
P.
like del x upon, just a second, del upon
Del
del
q by del
x.
x. Yeah, that's
Yeah,
right.
del upon del x, del upon del y p q. So del q upon del x. Okay. So that a cross product, right? The vector product. Q. Okay. Okay. Just I have written p in both the term. Del p.
Yeah.
Yeah. Del p with respect to y, and yeah,
And
del
del
q
Q
with
with
respect to
respect to
x.
X.
Now if I try to make a vector product here, so del upon del x, pq del upon del y, right? So this has to be 0.
So I don't get why you're doing this. Why can't you do to know that it's conservative? Why can't you integrate t in terms of dx and q in terms of dy,
Hmm.
and then if those are equal, then you can prove.
Yeah, that
If you know
that
what I
will
mean,
do.
because
That will do here. Like to find out the potential function, the same stuff is going to come. That what you are saying. But this is the easiest way to
oh,
show whether the vector
oh,
field is conservative vector field or not. If it is a conservative vector field, then we'll find out the potential function only to find out the work done. Because if we are given the endpoints, right? If we could find out the potential function, we simply apply the endpoints like this to
so
find out
I
the
got how you. I realized how you got this. This is you got this on the mixed derivative being equal.
yes.
Earlier, this thing was done,
Yes.
and now the other
Yes.
one is
Now
it's
the
being
now it's switching.
differentiated in terms of the
Yeah,
other.
now it's switching. That's why the
Yeah.
x component is to be differentiated with respect to y, and the y component is differentiated with respect to x. Okay,
Got it. Mm.
and that is that what we found here is that is curl, right? So curl has to be 0.
Mm. Mm.
The curl is
Mm.
0 basically if you have this expression,
Mm.
right?
Right.
Okay. So if the given vector field is conservative, then only we can apply the fundamental theorem of line integral that is written on your screen. Okay, we simply use the endpoints, we apply that into the function, and we get the work done. Okay, write down one question based on this.
So can you scroll a little up?
Yeah,
I
yeah,
just
yeah,
wanted
yeah,
to
just
copy
a
the
sec.
last line.
Yeah, just a sec. So this is the question. We have to find out work done on this vector field from a00 to b minus 1 comma 1.
So was there more steps that you were going to tell us about?
Yeah, there will be like the 2 3 steps involved to find out f.
No, no. I was saying while you were explaining, you only told us the first step of showing that f is conservative. Then you didn't, I think, tell us step two and step three.
Yeah, then we need to find out f, like we need to find out the potential function, and that I'll explain through this example how to find out the potential
Okay,
function.
okay, got it.
Now see
Okay,
the above idea will work only when the given vector field is, come on,
conservative.
conservative vector field.
Yeah.
And how do we show the vector field is conservative vector field? We just find out the partial derivative
We
of
show
x
curl is 0.
component of vector field with respect to y, and find the partial derivative of y component of vector field with respect to x. If they are equal, if they matches, the given vector field is conservative vector field, right? So this is the vector field. This is p. Sorry, this is p, and this is q. Okay. Now we'll find out derivative of P, partial derivative of P with respect to what?
Yeah, and q
Y.
to x.
Y
Like,
with respect to Y.
yeah, but q. No, no, I'm saying del q del x is equal to
Yeah,
del
del
q
Q
del
del
x.
X. So del Q upon del X. Now let's check that whether they are equal or not. So what is the partial derivative of P
Both
with
are
respect to Y? That's 2. And partial derivative
2.
of Q with
And
2.
respect to X
And
is
2
2.
again. 2 again.
So both are equal.
yeah,
It means the vector field x comma y comma z, okay, there should not be any z here, it's based on 2D, uh, is conservative vector field. Okay, and if it is conservative vector field, our line integral is become path independent, means instead of this I can write del f dr, and that is nothing but f of b minus f of a, where a and b are the endpoints, right? Now let's find out, if suppose we have conservative vector field, we can write f is equal to del f, right? Please listen carefully. If we have a conservative vector field, we can write capital F is equal to gradient of that potential function, which is del f, right? Isn't it? Now this del f, since f is this vector field, right? So 2y plus 1 I cap plus 2x plus 3 j cap, isn't it? It should be equal to the
yeah,
gradient of that function. Now,
yeah.
what's the idea to find out the gradient of the function? This has to be the partial derivative of that function with respect to x,
Hmm.
and this is the partial derivative of f with respect to y, isn't it?
Hmm.
Now, if we want to find out f from this, what we have to do?
Hmm.
We have to do
Uh,
entire derivative of
integrate
this.
p.
Yes.
Yeah, yeah, yeah,
So we'll entire derivative of this with respect to x, right?
yeah.
So that is 2y plus 1 integrated with respect to x. What is integration of
2xy plus
2yx
2xy
plus x
2xy plus x
plus 1 plus x, sorry,
plus
plus
x.
x,
plus x
yeah, plus x
plus plus c plus x
plus
plus c
plus c,
c.
okay, means
Yeah,
constant. So see, if
yeah.
we are integrating with respect to x, we got this partial derivative, that was the partial derivative of f with respect to x. So in that case the constant may be y, because we are finding out the partial derivative of that function with respect to x. So in that case my constant may be in terms of y. Are you getting that? So can I
Hmm.
write g of y instead of c, because whatever y containing terms are there in the given function, that is treated as constant while finding out the partial derivative with respect to
Yes.
x,
With respect to x. Yeah.
Yeah, yeah, yeah.
right? So instead of like writing just c, I will write g of y, some other function in terms of y. Okay, now this is my function, this is my function, isn't it? What I'll do now, what else we have here is partial derivative with respect to y. Now understand this properly. This is not yet completed. We got function like it has g of y, which is not known to us, right? But we have one thing for sure,
Hmm.
that is the partial derivative of that function with respect to y. So if we just find out the partial derivative here, okay, with respect to y, we'll be able to find out g of y here. See, let me know the answer. If we find out the partial derivative of this function with respect to y, what we get?
Get x, y. Oh, 2x.
Partial
You're
derivative of
saying
that
this
function.
respect to
Yes, we have to integrate,
okay,
differentiate this with respect to y.
2x plus g dash y.
2x
two
plus
two x yeah.
g dash y.
G
So
dash y. Yeah.
see, we got this partial derivative with respect to y. We already have partial derivative with respect to y, isn't it? This should be equal,
Yeah.
right? This should be equal because they are the partial derivative of the same function, isn't it?
Yeah.
So we'll set them equal. So that is 2x plus 3 should be equal to 2x plus g dash y. Then what is our g dash y?
3.
3. But in the function
Yeah.
we have g of y. So how to find out g of y if we have g dash y?
Integrate.
Great.
Integrate.
We get 3y.
So g of y is equal to
3
3y
3.
plus constant.
plus c. Plus c now. Okay. So what is my function then? F of x comma y will be equal to 2xy plus x plus 3y plus c. Right? We'll insert this there. Did you understand this?
Hmm.
Now, if we got the function, how to find out the work done? The work done is this, the line integral of f dot dr. But since the f is conservative vector field, now we can simply apply the fundamental theorem of line integral. So that will give us f of b minus f of a. What was the endpoints? The endpoints was 0 0 minus 1 comma 1, right?
Hmm.
So we simply apply that those endpoints here. 0 0. Okay, so minus 1 comma 1 must be plugged first. So minus 1 comma 1 plus minus 1 1 plus c. That c will cancel out automatically. Okay, c 0 minus c. Okay, the first endpoint is 0 0. So when we plug 0 0, everything going to be 0 except c, and that c will cancel out. So minus 2 minus 1 minus 3 plus 3. So we get 0. So work done is 0 in this case. Okay. So basically the main thing is we are not like considering what curve we have, along what curve we are going from one point to another. Okay. If we have a conservative vector field, the that line integral is path independent. Got the idea here? If we want to move a particle from one point to another, no matter which path you choose, the work is going to be same, right? Because the given vector field is conservative vector field. If the given vector field is conservative, then only this idea works. Make
Yeah.
sense?
Yeah.
So as I promised you, like we no need to use parametric equation, we no need to do difficult integration. This is like more easier in the previous concept. Done?
Yeah.
Yeah.
Okay. Find work done on f of x comma y is equal to x e raised to 2y I cap plus x square e raised to 2y j cap from a 0 comma 0 to b minus 1 comma 1. Okay. So what is our first step?
Prove that it's conservative by
Yes.
equating the
Yes. So first of all, we have to prove that the given vector field
Del
is conservative vector field. So we will
del
calculate,
p by del y is equal
yeah, del p by del y.
to del y.
Yeah, please correct me if I am wrong somewhere. Del q by del x. Yeah, it should
Del
give
x.
you the mixed partial derivative like of the function. Yeah. So what is del p y del y with
is
respect to y? We are finding
Del
out.
p by del
So that will be 2x e raised to 2y, isn't it?
2x e
X
raised
is
to 2y.
constant.
x to the power, yeah, x to the x e to the power 2y by 2, right?
Derivative.
Derivative.
Sorry, into 2, my bad.
And del q upon del x is 2x e raised to 2y.
2x e
So they are
raised to
equal.
2y.
Yeah, they are equal.
Yeah.
It means f is, I can write like this, since del p upon del y is equal to del q upon del x, therefore f is conservative vector field.
Hmm.
Now if f is conservative vector field, I can write f as del f, okay, gradient of some other function for f of x comma y, and the whole idea like to find out work done will be reduced to f of b minus f of a. Okay, because if we have a conservative vector field, then only this will equate it. F can be replaced by del f. Okay, now what is del f here? Del f is given, that is our vector field x x e raised to 2y I cap plus x square e raised to 2y j cap, right? That's
Hmm.
del f. Now if we have this, then we can write that will be the partial derivative of the given function with respect to x. Okay, it must be that term. And the second is partial derivative of f with respect to y. We would have find this, then we found the gradient of the function. We find the partial derivative. So that p is basically the partial derivative of the function with respect to x, and that q is partial derivative of the function with respect to y. Okay. So if we have a derivative
Hmm.
function, we can definitely find out the function by antiderivative. So f of x comma y will be integration of x e raised to 2y dx, right? Isn't it?
Yeah.
And we are integrating with respect to x here. E raised to 2y is constant. So x square upon 2 e raised to 2y plus, what should I write here after this? Should I write just constant or something else?
Gy.
G of y.
G y. Yeah.
Because we have integrated with respect to x, so other than x everything is constant. So the constant may have y. Okay, So that's why we should write g of y there. Now we'll differentiate this with respect to what, Mano? We should differentiate this function with respect to what is our next step?
So del f del y, del
Del
f
y.
del y, we get
Yes. Del f del
uh,
y.
yeah,
So what we get here?
we get 2
X square upon 2 is
2
constant.
2
E raised to 2y into 2 plus g dash y.
yeah. So x square e raised to plus b dash. Yeah.
So x square into e raised to 2y plus g dash y. This must be equated with what?
To what we found,
That's zero.
2x plus 2 2x
So
plus
gy is c, a constant.
Yes, we already have the partial derivative of the function with respect to y. We'll equate them, right? So what we get?
Hmm.
So g
So
dash
is the
y,
work done?
yeah,
Is the work done e square by two?
yeah, we'll find out that. So please answer this. What would be our g dash y here?
Zero.
0.
0. So if we have z dash y equal to 0, what would be gy then?
C, a constant.
Constant, right? Any constant.
Yeah. Yeah.
Okay, fine. So what is my function then? F of x comma y is equal to
X square
x
e to
square
the power 2y by 2
to e raised to 2y plus
divided
c.
by C.
Okay. Now the work done is,
Hmm.
what will be work done? That will be
Work done
like f of,
is
what
e
are the
square
points?
hmm.
0 0 minus 1
B
1.
minus F.
So minus 1 1 minus
Yeah.
f of 0 comma 0. We'll use this function. So 1
Hmm.
1 square e raised to 2
But e
upon
raised to
2
2.
plus c minus 0 minus c. So the work done is e
Equal.
square upon 2. Did you understand this? The whole process
Yeah.
here.
Yeah.
Okay.
Yeah.
Now solve the next one.
Yeah. So could you scroll up one second?
Yeah, yeah. More.
Yeah, enough.
Okay. So next question is f of x comma y is equal to x square plus y upon x I cap plus y square plus ln x j cap 1 comma 0 b e comma 1. Find out the work done.
So
Yeah,
I did. I'm not getting them equal.
yeah. Then you can go ahead.
I'm not. It's not being conservative. I think.
You're not getting them equal. See, we'll differentiate this with
Oh, sorry.
respect.
Sorry, sorry. I, I don't. I'm always integrating. Sorry.
Yeah,
My bad. I mean, I don't. I always.
yeah. Repeat what you are doing. Like, if you are integrating, repeat. Like,
Yeah.
say in your mind loudly.
Yeah. Yeah.
It is just 1 by x is equal to 1 by x, right?
Yeah. Yeah.
Yes.
Yeah.
Yeah. So I got the answer.
What is the answer?
E cube by 3 plus 1, right?
Perfect. What about you, Mano?
Yeah, almost one.
Okay. So I'm writing down the steps. Please verify there. Del q upon del x del p upon del y. So partial derivative of q, this is q, this is p. So partial derivative of q with respect to x is 0 plus 1 by x, and partial derivative of p with respect to y is 1 by x. Okay. So they are equal. So f is conservative. So f is conservative means f is equal to del f for f of x comma y, and del f is equal to x square plus y by x I cap plus y square plus ln x j cap. So the first term is partial derivative of f with respect to x, and this is partial derivative of with respect to y. Okay. So f of x comma y is equal to integration of del f upon del x with respect to x. So which is x square plus y by x dx, derivative of x square with respect to x, so y ln x plus g of y. Now we'll find out the partial derivative of this with respect to y. So which is ln x plus g dash y. We set this equal to the given partial derivative, which is y square plus ln x. It means my g dash y will be y square. So g of y will be integration of g dash y, which is y cube upon 3 plus c, right? So my
Yeah.
function is x cube upon 3 plus y ln x plus y cube upon 3 plus c. I'll simply find out work done by plugging these values, and this will give you e cube upon 3 plus 1. Done, Mano? Any mistake?
Yeah. I have, so integration of del f by del x dx.
Yeah.
So there I understood. I got that also. Then
Since this is function
so
now,
then we
and we have something
yeah.
about that function, which is the partial derivative of that function with respect to y. So to have some idea about g of y, we differentiate this function with respect to y. Okay, we find out the partial derivative of this function with
Okay.
respect to y, and we can equate them after finding out the partial derivative. That should be equal if it is conservative. So here we find the partial derivative of this, and this should be equal to this, right? The given partial derivative. And when we equate, we
That
find
is
that g dash y is nothing but y square.
yeah. Okay. So this and this. Yeah.
They have tried this
Y
one.
squared. So gy is y by 3. Yeah. And y cube by 3 plus c.
Mano done with the previous one.
Yeah. Got it. Yeah.
Okay, please try this one. Need to find just potential function.
Yes. Yes, I got it.
Okay, we'll wait for
It's
Mano.
x square plus y square.
I'll write down the answer here. So please dictate Dev. What is the
The
partial
answer.
derivative of, yeah, no, what is the partial derivative of q with respect to x?
1
Um.
upon 1 plus y square.
1 upon 1 plus y square.
Yeah.
And what is the partial derivative of p with
Right.
respect to y?
Same.
Same.
Same. So if they are
Same
equal,
thing. Yeah.
the given vector field is conservative. Yes, they are equal. So f is conservative. It means f is equal to del f. Okay. Now f of x comma y will be integration of del x upon no del y up, sorry del f upon del x dx.
Yeah.
So the partial derivative was x plus tan inverse y d, and we integrate this with respect to x. So 1 upon 2x square
Yeah.
plus
Yeah.
x tan inverse y plus
X tan inverse y plus g of y.
g of y.
Yeah.
So now we'll differentiate this,
Yeah.
okay, with respect
Yes.
to
With
y.
respect to
Y.
Y.
y. So we get x,
So we will get
You
x
get
upon
x
x
1
over
plus y square plus
1
g
plus
dash
plus
y.
y,
dash.
1 plus g
Yes.
dash y. Yeah.
And what was
In
g dash,
next line, this
like
is
what
equal
was the
to,
partial derivative? You will equate that with this.
X plus
yeah.
y
So g
by
dash,
1 plus y square.
yeah. So g
Yes,
dash y
so
is
the
y upon
partial
1 plus
derivative
y square.
was x plus y upon 1 plus y square. So what is g dash y then?
Yeah. Y
Y
by 1 plus
1
y
plus
square. Yeah.
Y square. So if g dash y is this, we will integrate, right, to find out
Yeah.
g of y. So that is
Which is
this.
half ln 1 plus y square plus c. Yeah.
So half, yeah, perfect. Half ln 1 plus y
Yeah.
square
1
plus
plus
c
y plus c.
plus c.
Yeah.
So
Yeah.
our function will be then 1 over 2 x square
X,
plus x tan inverse
x
y,
tan inverse y plus half ln 1 plus
right?
y square plus c.
1 plus
Yeah.
g of y, which is plus half ln 1 plus y square plus c. This is the function.
Yeah.
yeah.
Okay. Now the next question is f of x y z is equal to cos y I cap plus g square minus x sin y j cap plus 2yz k cap. Okay, from 1 comma 0 0 to 2 comma 2 pi comma 1. Okay, so first of all we'll find out curl, right?
Hmm.
So curl of the given vector field is I j k del upon del x del upon del y del upon del z p q r. Okay, what is the partial derivative of r with respect to y? See, first of all, make sure that this is p, this is q, this is
2z.
r. Yeah. So partial derivative of r with respect to y is 2z. Okay.
Yeah.
Then partial
Yeah.
derivative of q with respect to z, that is again 2z. 2z minus 0
2z. Yeah.
I cap minus, we'll put j cap later. So that is partial derivative of r with respect to x, which is 0.
0.
Yeah, minus partial derivative of p with respect to z,
Hmm.
so that
Which
is
is
0.
again 0,
0.
plus what, partial derivative of q with respect to x, isn't it?
Which is minus y. Yeah.
Minus sin y, and then partial derivative of what, p with respect to y.
Partial. Yeah. Yeah, which is
So
um, sin
minus of
sin y. Yeah.
minus plus sine y
Sorry,
a cap.
minus.
So everything will cancel out, you will get 0.
So minus sin y.
Yeah, so that become plus, and because of minus plus, this will
Ah,
cancel out,
okay. Got it. Got it.
right? So
Yeah.
now f is conservative, isn't it? It means f is equal to del
Hmm.
f. So f is equal to del f, then we will have all those partial derivatives, right? So we can write f of x comma
Hmm.
y comma z is equal to, we will first integrate the partial derivative of f with respect to x, like this, what I'm saying here. So what is partial derivative of f with respect to x? Which term represent the partial derivative of f with respect to x?
Sorry, I. What did you say, sir?
Which term represent partial derivative of f with respect to x? See,
P.
P.
t,
Cos
yeah,
y.
definitely,
Yeah.
that is cos y. So cos y dx. So the integration of cos y dx is x cos y plus, what should I write here? Should I write just g of y or something else?
G of y plus h
Plus
of
G of
z
Z.
plus z. Yeah.
I should write g of y comma z, because my function may have y and z together,
Oh.
right?
Correct.
So that would be written as g of y
Yeah.
comma z, and then what's the next step? We find out the derivative with respect to y, we'll find out here, and then that will help us to
Hmm.
equate this with the given partial derivative. So what is the partial derivative of this function with respect to y? Minus,
X sin.
derivative of cos y is minus sin y. So minus x sin y
Huh? Derivative. Huh? Correct. Yeah.
plus g dash y comma z. Okay, and this should be equal to what? This should be equal to the given partial derivative. It means q. So this should be equal to z square minus x sin y, isn't it? This should be equal to z square minus x sin y. So what we get after equating? We get z dash y comma z is equal to z square, right? Now can we find out g of y comma z? So to find out z of y comma z, we'll integrate this with respect to y. So that will
Yeah.
be,
Z square Y.
yeah, y z square plus, we have integrated with
Z.
respect to y. So h of z, we'll choose another term to represent the
Mm-hmm.
constant function, which is h of z. Now our function is f of x y z is equal to x cos y plus y z square plus h of z. Now which partial derivative is still left?
Mm-hmm. The Z one.
The z
With
one.
Z. So third one. Yeah.
Yes.
Yeah.
So we'll differentiate with respect to z. So that will be uh, 2yz plus h dash z, and we will equate this to the given partial derivative of f with respect to z, and the given partial derivative of f with respect to z is 2yz, right?
Yeah.
So 2yz, this is given partial derivative. So when we equate them, we get h dash z is equal to 0. It means
Zero.
h of z is
It's
equal to
constant.
some constant.
Constant.
So what will be my function then? X cos y
X
plus yz
plus
square
Y Z plus C.
plus c. Perfect. Now we'll apply the limits to find out the value to this. Okay. So if
Mm.
the work done is f of 2 comma 2 pi comma 1 minus f of 1 comma 0 comma 0. So this will give you 2 cos 2 pi plus 2 pi 1 square plus c minus 1 cos 0 plus 0 0 square minus c, and this is also minus actually.
1 plus 2 pi. I think the answer is 1 plus 2 pi, right?
1 plus 2 pi. Okay, see, cos 2 pi is how much? 1.
One.
minus yeah,
One.
Cos
One.
2
one
pi
one
is 1.
one.
Yeah. So 2 plus 2 pi, c
2
will
pi
cancel out, and this is 1 again.
minus 1.
So
Yeah.
1 plus
So
2
2,
pi.
2 pi plus.
Yeah. So the work done is 1 plus 2 pi. Okay. So let me put up the homework question now. Find out work done on f of x comma y comma z is equal to y z square I cap plus x z square j cap plus 2 xyz k cap from 0 comma 0 comma 1 to 1 comma 3 comma 2. Okay, so this is for homework. I understood the concept today about the line
Yes, sir.
integral on the conservative vector field.
Yeah.
Okay, bye bye.
Bye, sir. Thank you. Bye.